Okay guys, so in this video we're going to look a little bit at what changed since last time. Quite a few things have happened, so let's get into it. Now, if we have a look at the actual application here, we can see that it's not much has changed from the perspective of our user. So all that we actually were doing was to add the ability to create a view, or rather have an oversight over the emails that have been sent. So if I now go here and I say foo and bar and I input some information like that, I hit send, we see that, hey, the email was sent successfully, and then we fish out the email from here. We still haven't implemented like the actual view of this, but that's coming up later. So now we have this way of just getting an oversight. Now, the reason why a lot of things have changed here is because we've arrived at this magical moment when the state management of our system has grown to a point where we can no longer just rely on React's own internal state API. And that puts us in a decision. Basically, we have to make a decision now because there is a shared state that needs to happen. I'll show you exactly where that happens. And when we get to that point, this is the magical part where you now have to decide, okay, what's the way of state management are you going to use? Now, there are a few that you can use. Very recently, you have something that was actually released natively for React, which is basically to have the provided consumer pattern and you actually have first-hand support for the context API. I did not choose to go that way. I decided to go with Redux because it's still, as today, because like most of the projects that you may face out there in the real world, it's going to most likely use either this or it's going to use something like MobX, for example. But I'm pretty sure that the React Native, well, not React Native, but React's native context is going to be kind of the thing that more and more people are going to be using. But for now, let's just stick with Redux. So let's go through the diff together to just kind of touch on the different things that have changed. So first and foremost, we have, as we saw here, like in the diff, not much has changed here. We added React Redux and Redux so that we can wire up Redux to React. Straightforward. And then we added a few new endpoints. Let's actually look at that. So basically, we've just switched out all of the different routes so that now, instead of having a single mock endpoint for getting the emails, we actually have multiple categories of endpoints, which allows us to grab specific categories of one endpoint. Now, we could do this. We could also have, if we want to be more REST-ish or RESTful, we could have had just a single entry point where we simply said /API/version1/emails and then use the query to determine which type of category we would want to use. I thought this was easier to kind of illustrate this way, less complexity, I suppose, but that's also a very feasible strategy to do something like that. And a common practice that you should be aware of is that prefixing your route with API and a version number like this is something that is very useful, because what's nice about that is that if you update your interfaces on the server, in other words, these endpoints start changing and so forth, and you need to be backwards compatible, it's easy for you to just copy paste this code, add a second line under here with a new version number and start implementing against that. So migrations gets fairly easy. And then we had a little bit of a change to the email model, as we can see here. So because the email model has now changed a little bit, because in order for us to be certain that we are getting the emails that have been sent, we need to actually have a state of some sort. We need to represent somehow on the model what state a email is in. So an email can be received. In other words, it's something that came to us from an external source. It can also be outgoing, and that's a state that we may need to look at later where, as a user, what we want is to have two ways of storing storage. Basically, what we want in the future is to have a local storage where we long-term store the user's email, and then we need either a queuing system or some type of batch job, or maybe we want to do something very even more maybe I'm not gonna say naive, but let's call it naive nonetheless, way of like sending emails directly as a user types in and like hits send, and that's one approach. But at the very least we need a way to store the state outgoing, and then finally we need to have sent. In other words, we have verified that the email has gone out into cyberspace and it's been received by somebody somewhere. And with that, of course, we've added this little extra help, like these extra helpers here. So we've added the state outgoing to our create emails function. Let's actually look at that in full size here. So we have this outgoing concept now, and we fixed a bit of a bug in the last video where I forgot to actually call the save function here, though, but it's fixed anyway now. So now we can actually create an email through our email service, and we can get a sent email by simply checking, all right, we want to find all the emails that are either outgoing or sent, because from the user's perspective, they don't really care so much if they've been sent or not. At least that's, maybe we want to make this just sent, I don't know. But since we don't have, at least for now, since we haven't implemented any logic that is actually going to grab outgoing emails and send them and set this to sent, we can keep it like this for now, I think. And then of course, since we did that, we upgrade our tests a little bit, and yeah, that, like, just making sure that we're consistent with our testing. And we added a few tests here as well, where you can see here now that create email has a bit of a, well, there's a little bit of more logic here now. So something that I like to do, which is one of the main reasons why we pass in, if you have questions about that, why I like to pass in the model into my services, is simply because I want to be able to do this sort of thing. I want to be able to, from the caller's perspective, dictate what the thing that I'm actually passing in is going to be. Because if I do this, I can, as you can see now, making a test for this service is super trivial now, because all I have to do is to mock a function, pass in an object with that mock function, and then I can do my assertions down here. And I couldn't, because I don't want to have the actual database reference like the Mongoose API. I don't want that, because if I'm going to use that for just services and basic logic, I'm going to have to spin up a database for every single test, and I don't want that, because that's going to be very unperformant long term. Right, so what we can see here is that quite a few things have changed in our entry point. So now we're grabbing the store from Redux and the provider from React Redux, and the provider is just a way for us to pass in the store, and this is where all of the state for the application is going to live, basically. So we wired this up with the reducers, and if you're wondering about this pattern here, this is something that is, I need to show you this, which I think it's a very nice plugin. So I use this Redux plugin for development quite frequently, and this is just what this is. It allows me to just check out, right, the different actions that are dispatched. I can go through and see like how the state came to be. For the most part, this is a tool that I use every single day, basically, when I work with Redux at least. And here we have our state. So we have an alert, an inbox, and a navigation list module, or state maintainer, if you will. We'll touch on that in just a moment. But that's basically what the syntax is about, so that plugin works correctly. And then we have our reducers, easy peasy for those of you who are familiar with Redux. That basically a reducer, all it is this is, as you can see here, alert, inbox, and navigation list perfectly maps to our state. And the way, I'm not going to go into details of how Redux works, but in essence what happens here is that there's this object that has a bunch of reducers that return submodules of that object, and they are responsible for holding and updating the state on the page. Alright, and then because we have this, we need to have a little bit of a look at the folder structure for this, I think. So the way that Redux in general is used is that you have the concept of a visual component and you have a container component of some sort. Now, the reason why you have this separation of concerns is because in order for you to actually hook a wire up Redux so that it understands that on every page refresh you actually should pass down the newly created state in an efficient, like basically in order for the page to re-render with the updated state, you want to have this pattern here where you connect these higher order functions that basically just take in the visual component and wrap these in like their own components. That's basically what it does. So we see here that we are past the dispatch function, and the dispatch function is basically allowing us to dispatch an action. The action here, close alert, is one of these actions, as you can see here. That's all it is. So you can see that that action here, close alert, that's being fired when I actually close the alert. The modal box that you saw, and that's where this dispatch comes in. This is the way that you communicate to Redux that, hey, I want this action to execute, I want this action to execute, etc., etc. So we add a alerts container that we are now referencing, and inside of that we simply have our, like the component we had earlier, which is just this dialog. And then I like to do this thing where I could pull out my reducer and my events and my actions. I kind of group them in this way because I like to keep my files small, and I like to keep them as leaf-like as possible, because when you have this pattern, instead of putting everything in the same file, it's less likely that you will create a circular dependency, and it's also more likely that you will be able to fix it if you do. Right. So that's the alerts container, and we've already looked at these alert events and actions. Once again, this is very Redux specific, so I'm not going to touch too much on every aspect of this, because I mean this little series of mine is not really about Redux and explaining all the concepts. But here we have our show alert action, basically, which is just an object that holds some values and has a type, and yeah, and then we have the close alert. And here we have our events, so we have some type of labeling system for the different events. And here's the reducer, where we have our initial state, and it's just, this is the function that you saw earlier in the reducers, which is basically all, think of it this way, all that's happening is that Redux is going to throw into this function the state on every page refresh, and if, or rather whenever an action is dispatched. And then we simply check the type. So if it's the close alert, we're simply going to update the state to set open to false. So we copy the state and return it so that the state itself now just holds the variable false, or open is now equal to false. And show alert is basically just going to set whatever value is onto the state, or that becomes the state, because yeah, reasons. That's the way I like to do it. Anywho, and then we have our app, which has gone through quite a few changes as well, so we'll probably just have a look at that entire file because there's too much on the diff going on here. So what we've done here is that now we are passing in the path to each inbox, which will make sense in just a moment. So we basically have different paths because the inbox is the common component, but what we want is to know which category of emails we want to get. So we use the same, I mean, it's the same, we are using the same component for each of these views, because I mean it's just a table with some data and some buttons, right? So for now it makes more sense to just have one component instead of having several, and simply passing in the path that is that we need to go to in order to grab whatever emails we want. So that's basically what's changed here. Oh, and one more thing I can see here, which is the alert. So earlier because we had this situation where, all right, now we need to make a decision on, all right, if we make a network request basically when we create a component by using this modal over here. So basically when I do this and I create a component, we need to have a way to show to the user that something went wrong or something went right. That's one scenario of this, but there's also another scenario which is inside of the inbox. We will see that in just a moment. And that is when I actually go to the server to grab all these emails, in theory, it's possible for the server to return an error or something to go wrong, and then we need to show another modal. And since the original modal was in this navbar component, and I didn't want to put another modal. I don't want to have a separation there. I just want to have one generic alert or modal component that just handles the different events, because it gets a little bit messy in my opinion if you have multiple modals on different places, when all I really want is to show the same thing. I just want to show some basic information. So I decided to simply move it up here into the application itself, which like this is the natural entry point into that, in my personal opinion. Anywho, that's where this idea kind of comes from, where I need Redux in order to represent the state between multiple components, and I also decided to simplify the alert a little bit instead of having several of those. And here's my app container, which is just this little, all it does is that it tells me if I need to show the alert, and grabs basically, as you can see here, what it's doing is that it's going to the state, grabbing the alert module, which is this module here. So this object here, it's going to grabbing these properties and simply passing it down into the component. And that's basically all it does. Right, now let's look at the inbox, where there's quite a few things that happened as well. So in the inbox, we have basically said that, okay, so when the component has mounted, we want now, as we said earlier, now we need to know what actually happened, like which path are we on, what are we going to get. So if we look at the inbox container here, we'll see that this, like, the basic thing we do is that we just grab the emails from the inbox, because that's where we store our emails. As we saw earlier here, the inbox state is just holding all of the emails. So here you can see these are all the emails that you're seeing over here. That's basically all that data. So that's what we're passing in, but the fetch email function is a little bit special. So the first thing we do is that we get our first input is going to be the path name. In other words, which path are we on? And then we set that to set the location accordingly, so we know where we are on the page. The location becomes important later, because in order for us to check these up, like to know which route we're on, we have this state over here. Let's close that down. So we can see that the navigation list only has a single property, which is called the path name, and that's mapping perfectly to where we are. And so that's the way we can inform this component that, all right, if I click here, I expect you to go red and change to another route and so forth. Then we need that state in order to show the correct color. So then we have this function here called fetch emails, which just takes in a path name, and this does some basic, we can actually have a little bit of a look here. So basically this is just a higher order component, or a higher order function actually, that takes in fetch, and then returns a function that expects a path name. The reason why I want to pass in fetch like this is very similar to the reason why email service should have the database connection passed in, because for testing purposes this makes things a lot easier, because now I can pass in whatever function I want and assert that this internal logic is correct without actually having a hard requirement to fetch that is really only available to me in the browser. And then all this is, it's just a path name, it's just a function that checks that if the path is equal to inbox important, like one of our known routes, it simply makes a fetch call to the corresponding API endpoint, so it gets the correct emails. And that's about it, really. And then, yeah, we do the thing we did earlier. So we get the response, parse the JSON, sort everything nice and clean, and grab and map over all of our data from the data that's coming from the server to inbox email, which is our declared model, so that we can trust, we want to have our own declared model on the client. That's a very good practice in general, I think. And then we simply dispatch an action where we set those emails on the object. And here is a bit of that logic I was talking about. What happens if this fails for some reason? Well, we want to show an error to the user, right? And that's why we need to have a dispatch, or the possibility of dispatching that there was an error to the user here as well. So we can't just keep this logic anymore in the navbar that we did earlier. So yeah, that's basically it. And then we moved some files, and here we have like inbox actions and some events. inbox reducers, like all of this stuff. I mean, I can show you these files. I mean, this follows the exact same pattern. We have our module, we have our internal, like our tests, our like internal components, utility functions if we need those, and then we just group everything by functionality, or rather association. And something else, did something else change? I don't, let's have a look here. So fetch email spec, well, we can look just through these tests. It's not that interesting. These are very simple tests where, as I said earlier, all this function really does is that it expects an input of a certain type of string, and then all that we expect is to get back the correct thing. But as you can see here now, when I call fetch emails, I can pass it mock fetch, and then I can simply assert that the mock fetch was actually called with the expected value. And as I said earlier, this makes it a lot easier for me as a developer to test this function, since fetch is usually just found in the browser. You can import it, of course, in Node as well, but since I'm not in the browser when I'm running my tests through Jest, I'm actually running things in Node. This makes things a lot easier. Right. And these were just basically moves. I mean, we've already looked at that. We have the navigation bar has been updated as well. So basically, this is the same principle as we saw earlier. But let's actually look at the navigation bar from inside of the component first and foremost, because there's most of this logic has stayed the same. But we've changed just one basic thing, and that is that on email sent, we pass in the path name that we found on the navigation list here. And we'll see in just a second why we do that. So here comes the path name. We show the alert with a success message saying that, hey, we showed you the correct thing. And this is why this is important, because now we want to know if we are on the sent mail route. And why do we want to know that? Well, it's actually very simple. If I'm on the inbox and I compose an email like this and I send that email, I don't expect anything to update on this page. But if I am on the sent mail part of this route and I send an email, as you saw earlier, this was the last email I sent, I would expect as a user to see, hey, there's another sent email because I sent the email right. And that's why we need to know where we are. We need to know if the path that we are on is actually sent mail. And that's basically it. And if we are there, we do the same, the same dance we did earlier, where we simply grab the emails from the server and we simply set them so that we basically go to the server and update. There is a good argument here for maybe not going to the server and grabbing all the emails like this, but maybe doing it in a more optimized way. But I think this is the simpler approach, and it's good enough for now. And then, of course, we have the error case where we handle errors. And as we saw earlier, if there was an error like this, on error, in other words, we do this network request over here and there is an error, yeah, then we simply show the error message. And yeah, that's about it, I think. Is there anything else worth talking about? Everything else is just basic like the adding in Redux stuff. This is the one thing I really don't like about Redux, and that is that there is quite a lot of boilerplate. I'm just going to be honest and say that. I mean, Redux is great. It's once you understand how it works, it's fairly easy to work with it, but it has a lot of boilerplate and wiring everything up and all that stuff. So it takes some getting used to. But this is basically it. We've added a few paths, as we saw earlier as well, like nothing special has happened. And what's great about this is that now we can go to our card here and we can simply move this over to testing, and we can start looking at the next thing. So let's see here. Do we have anything interesting here? Add support to view email drafts. All right, that could be interesting. The question now is whether or not this makes sense, because can we view drafts before we've actually created them? So maybe in this story we're going to implement both drafts to create a draft and then view a draft afterwards. That could be interesting. So we'll look at that in the next video.